My name is Kathleen Meil. I am the Director of Policy and Partnerships at Maine Conservation Voters and Maine Conservation Alliance. And I have the honor of co-chairing the Buildings, Infrastructure, and Housing Working Group, along with Michael Stoddard, the Executive Director of the Efficiency Maine Trust. Our working group was charged with developing, analyzing, and recommending strategies to reduce emissions and support resilience in Maine buildings. We had a really terrific multidisciplinary group with members who brought varied experience and insights and dedicated many, many hours over the last 8 months or so. A huge thank you to all of you. Thanks to members of the public who participated, and a really special thanks to Anastasia Heidegger, who has staffed the working group and been absolutely essential to our process. Because we are such a diverse group, we started by building a shared knowledge base with monthly meetings on specific topics and frequent presentations from outside experts, and always incorporated really robust discussion and brainstorming. So we talked about how the concepts we were exploring together might become actionable recommendations for policies and programs that could help Maine meet our long-range carbon reduction objectives and benefit the state's people, businesses, and institutions. We didn't shy away from the costs that would be associated with these recommendations, but we always looked for ways to maximize the benefits while mitigating the costs, and especially for our most vulnerable communities. We took a really inclusive and collaborative approach to developing those recommendations. We invited working group members to share any and all ideas, and our hardworking team submitted more than 40 straw proposals. Many of those proposals reflect the independent collaboration of multiple group members. Some came from members of the public, and they're all included in the appendix to our report. I'm going to hand it over to Michael and the next slide.
Thank you, Kathleen. Our work group was the Buildings, Infrastructure, and Housing Work Group, and so we are focusing mostly on mitigation opportunities in the state. How can we as a state reduce our greenhouse gas emissions from the perspective of the users of energy? So the folks who live in homes, you see 19% of the state's greenhouse gas emissions are coming from our residential homes, 11% from commercial buildings, and 9% from industrial sources like factories, paper mills, sawmills, and the like. So that's where we were focusing our efforts. And we were considering where the sources are coming from within these buildings, as well as the energy systems that are supplying energy to these buildings. This is just an image of a residential home, and it helps visualize some of the things we were looking at to think about where the greenhouse gases are coming from. What are the sources? Where exactly are they in our homes? And you can imagine that it's comparable in our businesses as well. And it's primarily coming from the energy that we use in those buildings. So you can see here that we have space heating and air conditioning. We have water heating in that cylindrical unit down in the basement. We have electric appliances and lighting throughout the house. And so we thought about ways, and we looked at ways that you could mitigate the emissions from those sources. Options like using less energy by improving energy efficiency of those appliances, or of course, weatherizing the shell of the building. You see the insulation up in the attic there. We could shift to cleaner fuels. If we're using a dirty kind of fuel that has a high carbon content, maybe we could shift to one that has lower carbon. Heat pumps are an example of a cleaner and a more efficient heating system. So there was a lot of talk about heat pumps, but also other kinds of heating systems, like you see modern wood heat in this picture here. And you see geothermal as an example down in the basement. So this is an imaginary home that has lots of heating systems, but that's actually representative of many homes in Maine as well. And finally, I don't want to miss the opportunity to mention how we're thinking about the future of Maine homes and businesses where they would be grid interactive. So you see here a solar panel on the roof, and you see a car down on the side, which is charging up. So these are all things that we were looking at in our work group. And let's talk now about the 6 strategies that we came up with to talk about these opportunities. So I'll just mention, we broke all the 40 different proposals that we received into 6 categories. The first one is about new construction in new buildings. The second one is about heating systems and cooling systems that go into those buildings, as well as not just new buildings, but also existing buildings. The third strategy relates to the existing building stock in Maine, and particularly the building envelope, or what sometimes is referred to as the shell of the building. The fourth strategy is a collection of sort of the best hits from those strategies that we think maybe could be some of the first steps Maine would take to more aggressively move in these directions, and taking advantage of publicly funded buildings to lead by example. The fifth strategy relates to the industrial sector, and the sixth strategy relates to how we need to modernize and optimize the size of our electric grid to accommodate some of the strategies we described. Kathleen, back to you.
Thanks, Michael. Strategy 1 is to improve the design and construction of new buildings. And we started with new construction because there is just so much potential to do better, to improve energy efficiency and resilience from the very beginning, to incorporate clean energy and low carbon building materials, and to make new Maine buildings net zero. So they use only as much energy as they generate, either on-site through rooftop solar, for example, or off-site. Now, it's possible to achieve those goals in existing buildings, and we'll get to that strategy in just a moment, but it's just so much more cost-effective to build them in the first place. It's the old ounce of prevention is worth a pound of cure thing. So our working group recommends that Maine develop a roadmap to reach net zero emission building codes by 2035. Building codes set the standards for building design and construction, safety and performance, and they tend to be developed by an independent council with significant stakeholder input and then adopted by states, including Maine. They're really our best tool for protecting life safety, ensuring consumer protections, and moving the market toward best practices. But that process doesn't end when we adopt strong codes. So our working group also recommends committing the training and resources necessary to support code compliance. That training will carry some modest annual costs, but the additional expense of building a net zero home will be more than offset by the lower lifetime energy costs. And that's before we even consider the climate benefits. So for example, we've got some modeling that shows that a new net zero home in Bangor would save the equivalent of more than 500 gallons of heating oil a year and reduce carbon emissions at a savings of 8 cents per pound. So that's pretty impressive. Michael, back to you for the next strategy.
Thanks, Kathleen. So this was the strategy where we looked at the heating systems that we're using in our homes and buildings. And one of the starting points for us was to get a better understanding of how the carbon emissions vary from one heating type to another and from one heating fuel to another. This is just an illustration you see on the right here of one comparison. You have in the blue bar an average existing oil boiler in Maine. 62% of the heating that we get in Maine now comes from oil boilers and furnaces. The orange bar in the middle is what a more efficient, high efficiency, modern oil boiler or furnace would typically generate. And we compared that in this case to a high performance heat pump, which is the gray bar on the right. And so you can see the carbon emissions profile from these 3 choices is quite dramatic. And if we could shift from what we use now to more efficient and high performing heat pumps, we would achieve that kind of a greenhouse gas savings with each unit. Obviously, heat pumps are not the only choice. This is just the one we illustrated here, but there was a lot of discussion around higher performing natural gas heating, modern wood heating, and also renewable fuels like renewable natural gas and renewable oils. So the question is, how can we accelerate this transition to cleaner heating systems? Well, number one, we talked about expanding and extending the financial incentive programs that we have in the state to promote the purchase of higher performing and lower carbon units. And then ultimately shifting to more of a regulatory approach where at some point in the future, maybe starting in 2030, we make a regulation that sets minimum requirements for greenhouse gas performance so that since new heating systems burn out about every 20 to 25 years, when it's time to replace that over the next 20 to 25 years, people are getting very low carbon emitting heating systems. So we talked about incentives, we talked about regulatory regime, and we also talked about developing mechanical licensing standards so that there is good quality assurance when people are having new technology installed that the equipment will work well and be serviced well. We're lucky in Maine, there's a universe of many qualified small businesses that can perform these services now, so we just need to keep that up. This is some modeling that was done by Hannah Pingree's office to show what might happen under a couple of different scenarios of switching to these lower carbon fuels. On the left graph, you see what the fuel mix would be if we shifted to one of the three scenarios, what we call the hybrid heating scenario, where 2/3 of the heating load in Maine is provided by heat pumps, electrical sources, and another 1/3 is coming from renewable gases and fuels. So the green bar on top is the electricity increasing over time. The orange bar below that is wood heat. Then you see the natural gas converting to more renewable natural gas. And you see in the blue on the bottom is conventional heating oil declining over the next 30 years and somewhat being replaced by some amount of renewable heating fuels. What you get if you do that is shown on the right side. The blue bar at the top is business as usual if we made no changes, but the three lines below it show the various scenarios of either going all electric or electric with some increased weatherization or electric plus a blend of renewable gases and fuels. And it just is really impressive to see that if we could push forward with this, just looking at these cleaner fuel sources, we could see an 80% reduction in our greenhouse gas emissions.
Our third strategy is to improve the efficiency and resiliency of existing building envelopes. And this strategy really acknowledges that even as we approach net zero building codes for new construction, we have a tremendous amount of work to do in Maine's existing buildings. As we air seal and insulate Maine homes, we make them more comfortable, we lower their heating and cooling costs, and we reduce their energy consumption and carbon emissions. And the good news is that we know how to do this. In the last decade, Maine has weatherized more than 20,000 homes through Efficiency Maine programs, and we've improved many thousands more through the low-income programs of Maine Housing and the Community Action Programs. Our working group recommends expanding those existing weatherization programs for homeowners of all income levels and ensuring that the programs meet the needs of low-income Mainers, including those who rent rather than own their homes. In order to make the same kind of gains in commercial buildings and for commercial tenants, we recommend adopting requirements that commercial buildings disclose their energy usage. This kind of policy has been implemented in a number of places, and it has a kind of positive peer pressure effect, holding building owners accountable and supporting continuous efficiency improvements. At its core, this third strategy challenges us to scale up already successful programs. But there's also room to do a little bit more. We could link weatherization to load management programs that use existing and emerging technologies to balance the demand on the electric grid. We could start a clean energy corps that leverages volunteer and entry-level workers to connect people to weatherization opportunities. We could create a deep energy retrofit pilot that systematizes the efficiency improvements that usually have to be highly individualized to each house. However we approach it, expanding access to weatherization programs, along with the transitions to cleaner heating and cooling systems and increasingly ambitious building codes, will help us over time make all Maine buildings more efficient and resilient. With strategy 4, we have the example to lead by example in publicly funded buildings. So we can accelerate our progress in buildings that are funded by us, Maine taxpayers. We recommend that the state embrace its leadership role and make the best decisions in new buildings and embrace the best practices for building systems, techniques, and materials. A quick word on building materials. Most of the time we focus on the energy that buildings use for heating and cooling and lighting, what's called operational carbon. But our working group spent some time learning about embodied carbon, the energy that is literally built in by our choices about building materials and techniques. There's some really intriguing projects, including in Maine, that use products like cross-laminated timber and wood fiber insulation, products that can be made in Maine with Maine natural resources and Maine workers. And we'd really like to see those projects and others like them showcased to expand awareness of and experience with emerging technologies. The thing that's really exciting about these lead by example policies is that they can transform the buildings that house our most vulnerable residents. So students in our K-12 schools, community colleges and universities, and low-income Mainers who live in affordable housing. So this is a chart from Avesta Housing, a Portland-based nonprofit affordable housing provider that has built a number of highly efficient developments and tracked data about them. There's a lot going on here, but if you look in the first line, you see that the initial cost of building a affordable housing unit that complies with current building codes is, that's the first line. And then the second line is the difference that passive design makes. That's one of the models for highly efficient construction. The more stringent standards do increase construction costs. So that's the first column. It's about $1 per square foot more to build to passive standards. But those standards also help you cut operating costs dramatically, almost in half, and reduce carbon emissions by an even greater percentage, nearly 60%. So this is really a win-win, providing low-income Mainers with access to highly efficient homes that are incredibly cost-effective and dramatically reducing emissions. Michael, I will hand it back to you.
We're coming up to the finish line here. Strategy 5 relates to our discussions about the industrial sector. And we had two high-level recommendations here. One was to continue and expand the successful programs that have been working in recent years, where the entities like Efficiency Maine are partnering with Maine's large industrial users. They're doing really impressive projects to improve their energy efficiency and convert their fuel sources to lower carbon fuels. Back pressure steam turbine is what you see was done here at the Hancock Sawmill in Bethel. There's an opportunity to do more of that work in Maine, but the funding is somewhat limited at this time. So one of the recommendations was to look at whether we could do more funding there and whether we could expand into other areas. But combined heat and power seems like a promising opportunity. The other is more fuel switching. And to be candid, because of the unique and unusual kinds of uses that industrials have for fuels, it's not so easy to convert them over to electricity like it might be for space heating in your home or your office. And we ultimately concluded that this just needed more work. This needs more study. We need some breakthroughs in the commercialization of fuels. And we think that Maine it's very important. Clearly, we want to be competitive in this area, but we also want to meet our greenhouse gas targets. So we really need something like a task force, an industrial task force, to keep looking at this issue. The last strategy, number 6, is fundamental to all the other things we talked about. If we're going to have significant electrification of heating and also transportation, we're going to need a more robust grid, a power grid, and we're going to need to be able to use it in, it's going to have to be more nimble and we're going to have the ability to manage load on that in real time. I know that this is something that the energy work group, who you'll hear from coming up, spent a lot of time talking about, so I won't belabor it here, but we had quite a bit of discussion around beneficial electrification and how this is going to put some increased focus on what our grid looks like and how we build it out in this state. So it's got to be a huge priority for us over the next decade or two. And to wrap it up, we just wanted to summarize what we think we would get if we could pursue these strategies. This is what came out of our work group. You know, you get increased energy independence. It means we're less vulnerable to the potential price swings and supply shortages from imported fuels. You have better buildings. They're more comfortable. They cost less to operate. They're healthier. You don't have as much combustion going on inside them. And they're more resilient to extreme weather. You have a modern, right-sized grid, and ultimately you have a more sustainable economy, and you have more economic development. So we think that that's a pretty positive story, and we're looking forward to see how this fits in with the rest of the work groups and to working with the Climate Council as they consider these proposals. Thanks everybody so much for your attention.